This is experiment 7 for digital electronics 2. First, here we have the peripherals, which we added PWM4 and timer 2. We are using the PIC 16 1509 to do this experiment instead of the regular or the PIC 16 F F18 875, which we used in all the other experiments. So here we have RC1 as the input as the output for our PWM, and then we have the system module, and the internal clock was changed to 2 megahertz. Interrupt module, we did not change anything. For timer 2, we changed the prescaler to 1 to 64, and then the timer period we set to 20 milliseconds, which is the period time of the SG90 servo. If you go to the PWM, or if we go to the PWM module, we have enable pin output and then timer 2 as the timer. The duty cycle does not matter since it will be changed later in the code. It says here that the period is 20 milliseconds and the frequency is 50 Hz, which is the PWM or the period time and the frequency that is needed to operate the servo, the SG90 servo. So this is the code. Here we are initializing the system, and then here we are creating an unsigned 16-bit integer called duty cycle, and here we are setting that value, or setting that variable to 0 to clear out any of the stored value. So here it starts off with the duty cycle of 30. To explain this, if we the PWM or the PWM period required to operate the servo is 20 milliseconds, and we need, or the pulse it needs is between 1 second or 1 millisecond to 2 milliseconds, and that is between 5 and 10% of the overall period. So here, if we set the duty cycle to 5, we get a PWM value of 30, and if we set it to 10, we get a PWM value of 61, which is why here we are setting the duty cycle to the minimum value supported by the servo, which is a 1 millisecond pulse, and then as long as it is less than 65, so it's supposed to be 61, but according to the guide we should use 65. Since it's close anyway, it should perform the same function. So as long as the PWM, or as the duty value is less than 65, which means as long as the servo is not turned to I think it goes up to 90 degrees, the duty cycle should just keep incrementing by 1, and then this is loaded into the PWM duty value. So it says the duty value of the PWM output to whatever is the current value of duty cycle, and then here it sets at a 20-second delay. So here, if the duty cycle is less than, so here if the duty cycle is greater than 30, so here if the duty cycle is equal to or less than, or if the duty cycle is 65, and while it is greater than 30, it will increment it downwards. So and then it loads the duty cycle again, and then another 20 millisecond delay. So what this is doing is this for loop would turn the servo to the right, and then if it take as soon as it reaches the maximum angle to the right, this for loop turns it to the left, and then it repeats the cycle. So this turns it to the right, and then this turns it to the left, and then it repeats that cycle.
This is the circuit for experiment 7. Here we are using a different microcontroller. We are using the PIC 1509. So since it's a different microcontroller, the wirings are different. Here we have VDD connected to the first pin, and VSS connected to the 11th pin. And then here we have a servo with the power connected to the or to the negative and positive power rails, and then the orange wire, which is the data input for the servo, is connected to our it is connected to RC4. I think it's connected to RC1 of the PIC 16. So if we power the circuit, the servo should start moving back and forth. So the servo is moving back and forth through the use of the PWM module, and then different duty cycles ranging from I think it's 5% to 10% is making it move between 0 to 90 degrees.